Okay, so we're looking at an example, x raised to the negative 2 plus 3 times x raised to the negative 1 minus 18 equals 0. I noticed that I can manipulate this to look like a quadratic. The trick on these that we're trying to manipulate to look like quadratics, usually if you choose, at least in this class, this u to equal this middle term, that variable or that expression of the middle term, in this case, x to the negative 1, not with that number in front, that normally works. And just to recall back from algebra, if we have power to power, that was multiplication of our exponents. And so I can rewrite this first term as x raised to the negative 1 power, quantity squared, plus 3 times x raised to the negative 1 power, plus 18 equals 0. So let's go back in and let's substitute in u wherever we see an x to the negative 1. So that would give us u squared plus 3u plus 18 equals 0. So now it's in the form that it would be nice if we could, oops, here's my case. This should be in minus 18. Like it doesn't factor. Let's write it down, right? Carry down that minus. So now it does factor. There's two numbers that multiply to negative 18 and adds to a positive 3. So u plus 6 and u minus 3. So 6 times 3 is negative 18. 6 plus negative 3 is 3. Set each piece equal to 0 and solve for u. So first case, u plus 6 is 0 when u is negative 6. And u minus 3 is 0 when u equals 3. So this is where we're not quite done because we're solving for x and not u. And so we have two separate cases. Let's look at when u is negative 6. If that's the case, we get negative 6 equals x to the negative 1. Couple ways we can handle this. We could rewrite this without a negative exponent and then solve for x. Or if we do something to one side, we can do to the other. And remember, power to power is multiplication. So if I want to make this a power, the exponent to be positive 1, I could raise this side to the negative 1 power, which I would have to raise this to the negative 1 power. Again, rules of exponents. Exponents are something that we use a lot in mathematics. If you have, let's say, b raised to a negative exponent, so let's say negative n, we make that positive by putting that underneath 1. So 1 over b to the n. So this negative 6 raised to the negative 1 power, I can write that as 1 over negative 6 equals, power to power is multiplying, so this would be x. Tend to like my x on the left, and I'm going to pull the negative out front. So this is the same thing as x equals negative 1/6. I would look back in my equation and I would ask myself, when I was solving this, did I raise both sides by an even power? Well, negative 1's not an even power. So as long as I did my math right, there's not going to be any extraneous solutions. Nothing that we get in our answers that doesn't work. Okay, so we also need to go to the other value we got for u and solve for x. So let's look at when u is equal to 3. So we're going back up here where we have what we set u to be. 3 is equal to x to the negative 1 power. So just because I said there was two ways to do this, let's look at this the other way. So let's rewrite this as a positive exponent. This is 3 equals 1 over x. Notice I need to clear my fraction. I can clear my fraction by multiplying both sides by my LCD, which is x. So here I have 3x equals, well, x times 1 over x is 1. Get x by itself, we divide both sides by 3. So x is 1/3. So notice that it was a lot faster if I would have used that rule of exponents and raised both sides to the negative 1 power I would have saw here, that would have been 3 to the negative 1 is 1/3. But either way, you get the same results. So a lot of times in mathematics, there's different ways to kind of approach equations or expressions and how you're going to simplify or solve. Okay, so same kind of idea. We're going to use the substitution to manipulate our equation to be a quadratic. So I'm going to let u be x to the 1/3 power. So I notice that this is 4. I know I want this to be a squared out here. And power to power is multiplying. So really what's inside of this parentheses would be this x to the 1/3, because 1/3 power squared is 2/3. So minus 3 x to the negative 1/3. Sorry, positive 1/3. I don't know what I said. Minus 1 equals 0. So now if we go back in and wherever we see x to the 1/3, we replace it with u, we now have a quadratic equation. So this is 4u squared minus 3, I see x to the 1/3, so that's u, minus 1 equals 0. So unfortunately, this is my coefficient a, the number in front of the square is not 1, so I'm going to use my AC method. My a value in this quadratic is 4, my c is negative 1. I'm thinking to myself, is there anything that multiplies to give me AC, which is negative 4, and add to give me my middle term of negative 3? And there are two numbers that multiply to negative 4 and add to negative 3. That would be negative 4 and 1. So I'm going to rewrite this negative 3u using those two numbers as coefficients in front of u. And so I'm going to rewrite that middle term using that. So I have 4u squared. I'm going to have a minus 4u plus a 1u, or just u. And then bring down my minus 1 equals 0. So if you can find those two numbers that multiply to give you AC and add to give you your B value of your quadratic, then you're going to rewrite the middle term using those two numbers and do factoring by grouping. So group the first two terms together, pull out what they have in common. So 4u squared minus 4u, those both have a 4u in common. If I pull that out, that's going to leave me with a single u minus 1. So notice the last two terms, u minus 1, don't have anything in common. But that's the same thing. That's what's inside my parentheses over here, u minus 1. And so think of it as that you're pulling out a positive 1. And I'm just going to write that 1 there just to make it you to see it when I factor out the parentheses. Normally, I wouldn't write that, is equal to 0. So now with this trick, I have the same thing inside the parentheses, this u minus 1. And so if I pull out u minus 1 from that first term, right, I'm left with 4u. Plus, and if I pull out the u minus 1, because I'm pulling out what they have in common, from that second grouping, I'm just left with a positive 1. And this is equal to 0. So I'm looking at when is u minus 1 equals 0, and that's when u is 1, and when is 4u plus 1 equals 0. We'll subtract 1, we get 4u equals negative 1, divide by 4, we get u is negative 1/4. Unfortunately, we're not done because we want to figure out what x is. Okay, so we know that x to the 1/3 is equal to u. So let's look at when u is equal to 1. So we have x to the 1/3 is equal to 1. So I can get rid of that 1/3 power. Again, by power to power is multiplying. So I think to myself, what can I raise both sides to? So if I multiply it to 1/3, I get 1. Well, that would be a 3. So I would have to cube both sides. Well, 1 cubed is still 1. Okay, raise both sides to an odd power, not an even power. So as long as I did my algebra right, when I plug these back in, it should work. The other one, let's look at when u equals -4. So I have x to the 1/3 is equal to -4. So again, we want to get rid of the 1/3 power so we can have x to the first power. We can cube both sides of our equation. So we get x is equal to, well, -4 quantity cubed. -4 times -4 is +16. 16 times -4 gives us -64. And so we have two solutions, 1 and -64. Okay, so those were just some more examples of solving equations that aren't quadratic originally, but if we do some substitution, we can manipulate it to be a quadratic and use our tools to solve.